If every wireless vendor supports the same 802.11ac standard, well, what makes one better than another? I mean, does standard equal commodity? Well, Cisco would say no, because they spent years designing a custom Wi-Fi chip exclusively for 802.11ac. And this focus has driven performance gains as high as 60% when compared to other standards-based vendors. How? Well, the internal architecture is so groundbreaking, some folks claim they saw a Roswell, New Mexico return address on some of the components. Now, just between us, situation. But again, that's just between us, okay? So let's look at some of the benefits with this standard. First off, you've got wider channels, which can increase co-channel interference. But second, you've got higher modulation, cramming more data into that same frequency if conditions are ideal. You've got higher data rates, which means more packets per second, which is increased load on the CPU, more mobile clients that are already sticking to act longer than they should, and high-density clumps of these high-bandwidth clients, which are only going to grow. You know, not to be negative, but you see how this works? It's 5 benefits along with 5 challenges that you have to overcome. Well, thankfully, Cisco spells relief HDX, or High Density Experience. It's a suite of 5 tools uniquely designed for today's wireless. First up, clean air. Remember, more channel space means more interference. This 80 megahertz wide channel is optimized for 11AC, and it's more than double the channel width of what you were getting with the older N standard. Now think of this as greatly improved hearing. When you can hear more, you need to listen even better. Well, Cisco's Clean Air offers the ability to detect and mitigate this increased inside channel interference. Improved visualization of the RF spectrum provides a filter to prevent degradation and suboptimal performance. Well, next up, ClientLink 3.0. Beamforming technology to optimize the RF signal. See, modulation is the ability to represent ones and zeros in a waveform. Increased modulation can allow more bits per waveform through changes in phase and amplitude, which means more data from the exact same frequency. 802.11ac offers 256 km QAM, which is a measure of phase and amplitude, which is now cramming 8 bits per waveform if conditions are ideal. I mean, this is the kind of efficiency that used to be limited to microwave connections with their parabolic dishes shaping really narrow beams. Well, Cisco's ClientLink 3.0 offers patented beamforming, focusing and shaping that optimized RF energy toward the client for maximum data rates at greater distances. Without ClientLink 3.0, it'd be really hard to get that robust 256 QAM connection that you expect, especially when your clients are moving around. All right, we covered clean air. ClientLink 3.0, our third item is turbo. Fact is, wireless clients are getting added faster than delusional ideas at a conspiracy convention. Each one brings more bandwidth-hungry applications, and there will come a point for any vendor when performance for everything just falls off a cliff. It's called the drop, and it may be closer than you think. You see, higher data rates means more packets per second, which is a greatly increased load on the CPU. Well, Cisco addresses this with more than just a custom Wi-Fi chip. They have dedicated RAM co-located right on the radio, decreasing transit time across the board. Well, this, plus multiple radio buffers, streamlines the entire data plane. Less load on the CPU, plus a more efficient packet scheduler, translates to better speed and scale. So remember number 3, turbo. In fact, ask any wireless vendor to demonstrate their 802.11ac drop. Cisco would love to. Number 4 is optimize roaming. You see, breaking up is really hard to do. Very hard, it turns out, especially for client devices and their access points. I call it stickiness. The stickiness is when client devices wait too long before they scan for a better connection. Optimized roaming forces a disconnection that allows clients to roam faster and more efficiently. Devices are detected as they move into a region of poor coverage, which is done by measuring data frames, not beacons. This detection can happen before going into a dead zone where a device may only hear the beacons. And this benefits the end user and the AP itself, which is good for all users. Sticky clients that maintain poor connections will negatively impact otherwise well-behaved clients. So optimize roaming. HDX relief number 4 prevents this issue. And this brings us to number 5, RF noise reduction. This is about reducing noise between access points. I mean, you know that channel planning is a critical part of good wireless design and placement. The difference between 1 and 2 meters is huge. Well, RF noise reduction allows neighboring APs to share the same channel to increase overlay density and get rid of configuration errors. RF noise reduction could also allow you to deploy more APs in a given area to meet strenuous service level agreements, perhaps. So there you have it. 5 benefits of 802.11ac that come with a few addressable challenges, thanks to Cisco's HDX high density experience. I mean, this thing is amazing. Now, where do I return this? Just click. The truth is out there.